So, welcome back. We're talking about the development of the urinary system, and now we'll talk about the kidneys. In this section, we'll see how the collecting system of the kidney develops, then, we'll see how the excretory system of the kidney develops. We'll see how the communication between these two systems actually take place, and then we'll see how the kidney attains its final adult position as well as its adult site, and we'll see the adult form of the kidney, how it is attained. So a lot of attainment, a lot of movement in the kidney, and a lot going on in this section. So let's see what happens. So first of all, the sources of the kidney. So the sources of the adult kidney, there are two sources of the adult kidney. We'll see what these two sources are. The collecting system of the kidney is formed by a different source, and the secretory system by a completely different source. So we have the metanephros, and the metanephros is responsible for the formation of the secretory system of the kidney. And then we have the ureteric bud. The ureteric bud is responsible for the formation of the collecting system of the kidney. So we'll see what happens. So referring to the figure, this is the mesonephric duct. This ureteric bud is formed from the distal end of the mesonephric duct, and it tends to grow cranially towards the metanephros. So the metanephros was responsible for the formation of secretory system, and the ureteric bud for the collecting system of the adult kidney. We are talking about the development of the collecting system now, so we'll talk about the ureteric bud. So the ureteric bud, it arises from the mesonephric duct. This is the mesonephric duct in blue. It arises from the caudal part of the mesonephric duct, and then it grows towards the metanephros. So the distal end of the ureteric bud becomes capped by the this metanephric blastema. So this is the metanephric blastema. So what actually the metanephric blastema is? It's a ball of rapidly proliferating cells that is responsible for the formation of adult collecting system. So the terminal portion of the ureteric bud, it is covered by the metanephric blastema. Now the growing head of the ureteric bud, it becomes dilated. So this was the ureteric bud, this is the growing end. Now it becomes dilated to form a funnel shaped part. This funnel shaped part is known as the renal pelvis or the ureteric pelvis. So this is the funnel shaped part. The funnel shaped part is known as the ureteric pelvis. This ureteric bud undergoes 11 divisions, 11 further subdivisions to form the major calyces. The major calyces are the first subdivisions of the first divisions of the renal pelvis. From the major calyces, we have the minor calyces. The minor calyces are the second divisions of the renal pelvis. From minor calyces, we have the collecting ducts. These are the collecting ducts, and from the collecting ducts, collecting tubules are formed. So further generations are formed from the ureteric bud. So initially the ureteric bud, which arises from the this mesonephric duct, was covered by metanephric blastema. This metanephric blastema helped the ureteric bud to undergo further subdivisions to form the adult collecting system. Now the adult collecting system consists of the ureter in itself. The ureter then forms a funnel shaped part, which is known as the renal pelvis or the ureteric pelvis. From the ureteric pelvis, the first division of the ureter are known as the major calyces. The major calyces then undergo further divisions, which are known as the minor calyces. The minor calyces undergo further divisions, which are known as the collecting ducts, which undergo further subdivisions to form the collecting tubules. These collecting tubules come in contact with the secretory portion of the kidney, and hence the collecting portion and the secretory portion are connected to each other. So moving on with the development of the collecting system. Now the cells of the metanephros, they form the metanephric blastema. So we talked about this before. Metanephric blastema are actually a ball of rapidly proliferating cells that help in the formation of adult collecting system of the kidney. So how is this metanephric blastema formed? It is formed from the cells of the metanephros. So now when they come in contact with each collecting tube, so they condense, and this condensation they condense around this collecting tube to form a solid clump of cells, and this is known as the metanephric cap. So we'll see that in the figure ahead as well. So this metanephric cap is formed. So this portion, this is the developing ureteric, but this is the renal pelvis. These are the major calyces. So this is the metanephric blastema, which is exerting its effects on this developing system to form the adult collecting system of the kidney. So when they come in contact with the collecting ducts, the collecting tubules, there's formation of condensation around these collecting tubules, which are known as the metanephric cap. Now this metanephric cap is converted into a metanephric vesicle. It changes its shape from a pear-shaped vesicle to an S-shaped tubule, and it is now called the primitive renal tubule. So a primitive renal tubule is formed from the proximal part. Now the proximal part of the primitive renal tubule now comes to lie in contact with the collecting tubule, and the distal end now forms the Bowman's capsule. So the distal end is responsible for the formation of the Bowman's capsule. Now the capsule has been formed. This capsule is infiltrated by a tuft of capillaries to form the renal glomerulus. So the renal glomerulus has been formed. Referring to the figure again, this ureteric bud initially forms the renal pelvis. From the renal pelvis, we have the major calyces. These are the major calyces which are undergoing subdivisions to form the minor calyces. And from the minor calyces, we have these collecting ducts that have already been formed. So eventually, this forms a nephron. So now, these are the collecting ducts which are subdivided into the collecting tubules. So these collecting tubules, they come in contact with the cells of the metanephric blastema. So the cells of the metanephric blastema, they form a cap around it, which is known as the metanephric cap. This metanephric cap is converted to a metanephric vesicle. So this metanephric vesicle is initially pear-shaped. This pear-shaped vesicle changes its shape to an S-shaped tubule, and at this stage in time we call this developing structure a primitive renal tubule. So this primitive renal tubule, the proximal end of this primitive renal tubule now comes in close apposition with the collecting tubules, and the distal end, it expands to form the Bowman's capsule. So now a tuft of capillaries invaginates this Bowman capsule and is responsible for the formation of glomerulus in the Bowman's capsule. So the adult nephron is formed. So the section in yellow has been formed by the ureteric duct. The origin of this is ureteric bud, and the section in blue, this is formed by the metanephros. So the adult nephron has been formed. The adult nephron has various parts. Firstly, starting from one side, we have this glomerulus and the Bowman's capsule. Then we have this proximal convoluted tubule, also called the PCT. Then we have this loop of Henle. Then we have this distal convoluted tubule, the collecting tubule, the collecting duct. The collecting duct will finally collect the urine and take it to the minor calyces, the major calyces, and then the renal pelvis, and finally ureter. So this was all about the development of the kidney. Now we'll see how the kidney moves to its adult position. The development of the kidney actually takes place in the sacral region, and the adult position of the kidney is lumbar. So we'll see how the lumbar position of the kidney is achieved. So the first permanent kidney, it lies in the sacral region. This is the region where the first permanent kidney actually lies. Now there is differential growth of the posterior abdominal wall. So there is differential growth when anterior and posterior abdominal walls are compared. There's a reduction of the fetal curvature. Initially, there was a greater curvature of the was a lot of curvature of the fetus, which has now reduced. There is a reduction in the curvature of the fetus. Now this causes the kidney to ascend, to move upwards to reach the thoracolumbar region. Here you can see the kidney is trying to move upwards to reach the thoracolumbar region. The ureters now, they have to elongate if they have to conduct the kidney, if they still want to be the conducting channels of the kidney. So the ureters elongate as the kidneys, they move upwards or they ascend. So finally they come to lie into the thoracolumbar region in the abdomen. So now the arterial supply of the kidney. So initially when the kidney was lying in this in the sacral region, it was supplied by the median sacral artery. Here you can see the median sacral artery, which is the terminal branch of the abdominal aorta. It is supplying the kidney. However, now the kidney is moving upwards. As the kidney moves upward, it gets successive branches from the abdominal aorta. So these branches are called the lateral splanchnic branches, which continue to supply to the kidney as it is moving upwards during its development. When finally the kidney comes to lie in its proper thoracolumbar position, the definitive renal artery now supplies the kidney, and all other arteries which were initially supplying the kidneys are now obliterated, and this is the only blood supply of the kidney that remains in the adult circulation. So rotation of kidney, what happens, the kidneys are actually they are present anteriorly. Now with the development, as the kidneys they move upward, they also undergo a rotation, a medial 90-degree rotation, which causes the hilum of the kidney to face medially towards the inside of the body. So at first the hilum of each kidney lies anteriorly. So during the ascent, there is the 90-degree medial rotation, so that the hilum of each kidney now faces medially. Here you can see this is the hilum of the kidney, and it is both the kidneys, the hilum is facing medially, that is towards the central body axis, and this is how the rotation of the kidney takes place. So this was all about this section. In this section we talked about the development of the secretory system of the kidney as well as the collecting system of the kidney. We saw how the metanephros helped in the formation of the glomerulus, the Bowman capsule, the proximal convoluted tubule, the loop of Henle, and the distal convoluted tubule. Then we talked about the development of the collecting system of the kidney. The collecting system of the kidney consisted of the collecting tubules, the collecting duct, the minor calyces, the major calyces, the renal pelvis, and the ureters. We saw how these two developmental systems they come in apposition with each other and form the adult nephron, that is the functional unit of a kidney. Then we finally saw how the kidney moves up and how its blood supply is attained, how its blood supply changes from the medial sacral artery to the adult renal arteries, both of which are branches of the abdominal aorta. And finally we saw how kidney undergoes a medial 90-degree rotation, so that its hilum lies medially towards the midline of the body cavity. I hope you understood this section. For further sections, keep watching sqadia.com.